binomial distribution, and here's our formula with combinations. What we're going to do is we're going to try to tackle this using Pascal's triangle again. Okay, I'm going to try to tackle it. That way, we're not just plugging into this concept here. And what I'm going to do is I'm going to convert this. Okay, a lot of times in math we use like let statements. The formula is usually written where we're working with, and you'll see it here, a plus b to the n, right? So we have a plus b to the n. So I'm gonna under here I'm gonna say let, and I'll write it in red just so we can color code. Let 1 over x squared, okay, equal a. Okay, let, and this is a negative technically. Let negative 1/3 equal b. Okay, so now, and I guess you could say let n equal 5. Yeah, it's not a big deal. That let doesn't really make a huge difference for us, but let 5. Whoops, yeah, equal n. Okay, so I've now converted this to this. So what I'm going to do is I'm going to use my theory, and actually I don't really want to replace my, and I want to keep it as 5 because I'm used to working with a, b to the power of something here, okay? I want it to be to the 5th, and then I'm going to just substitute values back in. Okay, so we're going to try this. We'll see if we can build our Pascal's triangle. I still want this to technically be the number 5. So I need to build my triangle. So my triangle, the very first one is technically to the power of 0. Okay? My second one is to the power of 1. So we need to get all the way to 5. So we get 1, 2, 1. We know that's the power of 2. So we're going to need space here. 1, 3, 3, 1, power of 3. 1, 4, 6, 4, 1 is power of 4. And then 1, 5, 10, 10, 5, 1 is the power of 5. Does that make sense?
Yeah.
Okay.
So you just 1, 4, 4, 6, 6, 4.
Exactly. We're just kind of adding values in between, and then the ones always stay on the outside. Okay. So we're going to write these in as our coefficients. And remember I said that we use our a and b values. So I would have 1, and then we'd have AB plus 5, AB plus 10.
So this last term is the final answer?
These are the coefficients. We're not done because ours is a little more complex. If this was the question, a plus b to the power of 5, then yeah, we'd pretty much be done. We put the exponents on. But we're going to have to do some substituting after. Okay?
But this is the final coefficients?
Yeah, these, and you'll see they'll change a little once we plug values in, okay? But they kind of tell us what numbers we need to multiply by. That's a good question. Plus 10. So this is the tedious part. We just kind of copy it out. Plus 5 again. And then plus the value of 1 AB. Okay. So now that I've written that, I need to write my exponents out. So I'll quickly do that. Because it's to the power of 5, I know A is 5, then 4, 3, 2, 1, 0. So that A is kind of non-existent. We don't need it. And here, same idea. We just write it backwards with B. 5, 4, 3, 2, 1, and 0. Okay. This is great. This worked out really nice, except that's not what the question asked us. The question wasn't asking us to expand AB. It was asking us to expand 1 over x squared minus a third. So we're going to plug these values back in. I'm going to plug in my x and a half for all of the a's in here. And you'll notice the a's are to a power right now. Okay? And then we're going to plug in all of our, we'll do it in blue, all of our b values. We're going to plug those in for the b's. Now the b0 is not important. So we can plug them all in, and then we'll just do a little bit of multiplying to kind of figure out what our answer would be. So again, some substitution, and this is just a method of doing it. Our coefficients can stay the same. I'm going to write them in black now. So we have a, 1 is our coefficient. This a, so let's replace it. This is 1 over x squared, and then it's to the power of 5, right? And the b I don't need to write in, it's just the number 1, okay? So then the next one becomes 5. Same idea again.
Yeah, I see how
our a is 1 to the x squared to the power of 4. And now the b will be 1 over a third, and it's just the power of 5. So this is still multiply, right? So we just kind of fill these in. So I'll quickly do my best here. 10, the a value again is 1 over x squared, this time to the power of 4. Our b value is negative a third squared, plus 10 again. Did I write that right? 1. This should have been 3. Okay, the reason I knew that was wrong is because and all of your terms.
Oh, it has to go
Yeah, they must
5, 4, 3.
exactly. And another trick would be is they technically always have to add up to whatever our exponent was.
Right.
So 5 plus nothing
That's
is
what my
5.
teacher said.
4 plus 1 is 5. 3 plus 2 is 5. So because I'd written a 4 in there, I knew that was too high. I made an error when I was writing. Okay, A again. So this part's a little tedious. Last one was 3, so this would be 2. And the B value is a negative a third cubed plus 5 quarter squared. And this is a third to the power of 4. And then finally, the last term is just 1. And the 1 doesn't really matter. That 1, it's not going to change anything. So really, and the A kind of falls off, so it's really just negative a third to the 5th power. I just did it that way so we'd have some room. Okay? Does it make sense how I've set this up so far?
Can you explain
this part here?
Yeah,
sure. So what I did, 1 times anything doesn't change anything, right? And A to the power of 0 is 1. Any exponent, whether it was 5 to the power of 0, 10 to the power of 0, is always 1. So this is 1 times 1.
Okay, so it's 1.
Yeah. So really, the only term that has any
1 to the
significance
okay.
is that. So I only wrote that term in there. Okay. Okay. So now that we've done this, we have to do some exponent rules, but this would kind of be our last step. 1 times whatever this is. So 5 power of 2, we use a power law. Do you know power laws at all? Yeah, we multiply. So that's going to be x10.
So
okay?
1 over
1 over x10.
So
that's our first term.
Do you multiply the coefficient times the numerator?
Yeah, so we multiply it. First we deal with whatever, think of bedmass. We deal with whatever our exponent is in our brackets. So I dealt with this, and this becomes 1 over x10, and then times 1. But we already know 1 doesn't do anything. Not that it doesn't do anything, but it doesn't change our significant value. So this is the first term simplified. Okay? Then we get into our second term, and we have to multiply 5 times whatever this to the power of 4 is. That should be times negative a third. Okay? So I'm actually going to get a negative answer. So there's going to be a subtraction sign here. Okay? But let's first focus on this. Because we know our exponent rules, 1 to the power of 4 is just 1. And we multiply these two. So we get x, let's write it in here, x to the power of 8. So it's 1 over x to the power of 8. Does that make sense? Okay. Technically, times 5. Okay. And then times a third. So should I do this in 2 steps? You want me to write each of them out, or do you want me to do it all together in 1?
You can do it in 2.
Yeah, let's do it in 2. So plus 5. So we just did the bedmass part. And then times negative a third. Okay. So we'll just deal with the exponents to start. We'll keep all of our coefficients still. So we still have 10 times, this will become 1 over x cubed, 6th power. And this, let's do this part too. Because it's to the power of 2, it's negative a third times negative a third. So a negative times a negative is a positive. So this would be a positive. 1 times 1 is just 1. And 3 times 3 is 9. So I've just done my fraction there. Okay. And if you have a decent calculator, sometimes it will do the fractions for you and stuff like that. Okay. The next one, we get 10 times, we know that's going to be over 1, and we know this is going to be x to the power of 4. Are you okay with that? Mm-hmm. Okay. This one here, to the third, well, that's a negative times a negative times a negative. So it's going to be negative.
Negative 1, right?
Negative 1 over, and then it's 3 to the power of 3.
Negative 27?
Yeah, very good. So it's negative 1 over 27. That's what that is going to be. Okay. Plus the 5 still stays the same.
So you have to do the fractions manually, right? Unless you have a
unless you have a calculator that does it. But if your teacher says, I want things written as a fraction, then you have to be decent with your multiplication. You can use a calculator to do like 3 to the power of 3 if you don't know. Like for instance, 3 to the power of 4, probably don't know it off the top of your head. I think it's 81. You might want to double check it, okay? This will become x squared.
81.
Okay. So then we know when we do this, because this is positive, this will be a negative times a negative times a negative times a, it ends up being a positive value. Okay, 1 to the power of 4 is 1, and 3 to the power of 4 we just said is 81. And then finally, I don't know what 3 to the power of 5 is, so you do it in your calculator. But it's going to be plus a negative 1 over something.
243.
243. There you go. So we've just done all the exponents. So the very last step now is just to multiply, and I should have that in brackets, multiply all these terms together. Okay, so we got to know our multiplication of fraction rules. So, and it's okay, because sometimes that's forgotten when we haven't dealt with fractions in such a very long time. The first term is done. There's nothing to do with it, so I'm just going to write it out. 1 over x10. the next term, okay, I'll convert everything to a fraction. So when you multiply fractions, you do the tops by the tops and the bottoms by the bottoms. So 5 times 1, and actually before I do that, let's focus on this. We have a positive times a negative. So what's our answer going to be? Do you know?
Negative.
Yeah. So I'm going to write subtract because I know it's going to be a negative value. Okay. And now I just have to deal with the values. 5 times 1 is 5. So I know it's 5 over. 1 times x to the power of 8 is just x to the power of 8. And then times 3, well, that just becomes our coefficient. So it becomes 3x 8. Okay? That's a tough idea. Let's try it again on the next one. Okay? These are all positive, so I know I'm going to put a plus. I'm going to turn this into a fraction, so I just put it over 1. 10 times 1 times 1 is just 10 on top. Okay?
And then 9x6.
That's it. 9x6. Very good. Okay, next one. Positive or negative?
Negative.
Good.
Negative 10, 27x4.
Hey, there we go. Okay, next one.
5 plus 5.
Yeah.
81x squared.
There you go.
And then negative 1 over 240.
Yeah, that's it. It's already done. And there you go. It's a really ugly binomial, like we said, but it's done. And we used Pascal's triangle to help find the coefficients, and then we did some substitution to plug it back in. You could have used your binomial distribution, but it would have been similar. You still would have kind of used some substitution. So you would have been, these ugly steps you would have done either way.